So there are a couple of things. So my questions are concerning the possibility of doing the product realization work with you guys. There are a couple of things. One is the overall goals of this are to have students come and understand what needs there are for doing product development and some project ideas. Whether or not I should come and visit, I'd very much like to come and visit, but only if it would be useful for me to be there. I have the flight dates that I could get to come are the 15th through the 19th of December.
Well, I remember that Emilia apparently answered your email, and I don't remember now what dates she said that she was going to be around.
She'd be there the 10th through the 18th.
She did?
Yeah, the 10th through the 18th she would be there.
Okay.
So
let me just ask Vanessa, are you going to be here around that time, 15th to 19th of December? Most of it, Vanessa is going to be here too. Okay, so I'm going to be here. We can have Christmas together.
That sounds great, but I think I need to be back. That would be great. You know, I will come down there and we can work out some things that way, you know, in more detail.
Okay.
But just some ideas to talk about is, you know, I know that it's too late to have your students actually register for a course for this, but it might be nice if I have 20 students that can come. They're all undergraduates, all junior or seniors.
Undergraduates?
Undergraduates, yes.
And when would they be coming?
The dates are, here I have the dates. Well, our spring break is March 2nd, and it runs through March, I think, 11th. But I have the dates written down here. I just want to make sure.
They would come during the break?
That is our spring break, yes. Yeah, it's March 2nd through the 11th.
But they would come during the break?
Yes, they would spend, yeah, we would spend our break there.
Okay.
So some of the things that would be nice to be able to do is to let them work with a faculty mentor and or a student volunteer or two. I have some things that we can do that might be able to make it worth the while some students to work with us. And what we'd like to do is be able to do a market study. You know, figure out what market needs there are for sustainability products.
In Brazil? In Brazil?
Yes. Yes, absolutely.
Okay, well, all right. Well, when you come in December, I guess we should then decide whether, especially the faculty, would be from which departments, from which faculty, because it's a very interdisciplinary area, no? So,
yeah, absolutely.
Okay.
That's great. The students, I have half of them are from engineering, different backgrounds in engineering, and half of them are from the business school.
Okay.
A large portion of them are marketing students.
We don't have any expertise in that. Remember that. We are very academic architects.
Right, no, that's fine. This course is interdisciplinary. So.
Okay.
And so, you know, some topic ideas that we had thought about based on your presentation and this summer and some discussion, a lot of them do revolve around architectural needs.
Okay.
Like ventilation, reflective solar lighting, different types of shower systems, water availability. But, you know, we're open to other areas that you folks would find interesting to have undergraduates explore project ideas.
Okay.
Okay, so that, and then there's just one more thing is, we have the possibility here of being a test site for a new online collaborative software program called Illuminate. And what it does, it allows people to remotely code design documents while looking at the same thing and interacting and meeting online.
What's it called? Illuminate?
It's Illuminate. 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 They have a website, and I can arrange for if you want to have a demonstration. And if we get to be a demonstration project, we get to do this for no cost. So that's what I'm trying to set this up as, to be a no-cost demonstration project for us.
Okay, that would be Regina's interest. She's our collaborative person here and the software lady. So maybe she should answer you if she's interested in how she would be connecting with you with that. Talk? You don't want to talk? Regina, answer.
This your software Illuminate. You mean code design? What do you mean when you say code design?
Code design.
Code
say
design.
We have.
Oh yes.
So we have one document. Say it's a spreadsheet. People can edit it from where you are at the same time where we are. People can work on the same document simultaneously in remote locations.
Next semester, I'll be giving a class in our graduate course that has to do with information technology used in building design. Maybe we can do something together, like use this this tool in this course. You think it's okay?
Sure. Yeah, I think so. I think it will be okay. I still have to work out a lot of things with our technology department here, but they were very interested in having us be a test site for that, which means that there will probably be some things to be ironed out as we go through it, but the exchange for that is it will cost us nothing. Otherwise, the software costs about $5,000 a year to use. So we will be able to use it for free if we become a test site for it.
Yeah, it will be interesting because two sites will be doing this course together. So, yeah, it's distributed here also.
Okay, sure. Okay, so we'll work that out. Okay.
Okay.
As I have more answers from our local people, I'll put them in touch directly with you so that things can be coordinated.
Okay, thank you.
Great, thanks. All right, so just to move on to a couple of the more mundane things. One is, so for these 20 students and myself, being able to stay somewhere at UNICAMP. And is that Fun Camp or Foundation UNICAMP? Or,
the Fun Camp, I have to see if there is room. I will check on that and we'll come back to you. Because
okay, great.
Since it's a fun camp, it's very popular.
I hear it's very nice. Also, is there a place for students to eat meals nearby where they will stay? Assuming they stay there, is there a place to eat there?
Yeah, there are plenty of places to eat.
Okay, great. And then the last thing is just medical facilities nearby. These are things that I need to write in my proposal to the local people here so they know that the students have access to medical facilities.
Will they come with medical insurance?
Yes.
Because we have a university hospital which has a service for our students, but there also is a hospital right next door to us, which is a private hospital, where there is a 24-hour clinics service available. So you're very close to all sorts of clinics around here.
Great. If I could just get the name of that facility, that would be very helpful.
Yeah,
even if it's a website or something.
Yeah, I'll send you by email. It's better because otherwise I would have to spell it to you in Portuguese. bit complicated.
Okay? Oh, that's okay. Yeah. Well, I'll figure it out. Okay, and then just two more mundane things. One is, transferring funds to pay for these things, if I can understand a little bit more about how that will happen, so that I can make the arrangements necessary to transfer the funds for paying for housing and that sort of thing.
Well, the fun camp one can pay with a credit card. Okay?
Oh, okay.
You can pay all your meals around here too with credit card. You can get local money from machines, you know, from what you call them, those ATM machines.
Okay.
Now, bringing funds over for us to spend some stuff for your students and you yourself. Vanessa had some ideas here. Maybe she should talk. Remember that we would open an account and
Probably the best way would be that we open an account in the bank, and then you can transfer directly through the SWIFT code. We can give it to you. I think it's the best way. You have to pay, I think, a percentage of the value, but it's nothing very difficult to do.
So in our foundation, in our support foundation called FunCamp, FunCampi, we can open an account there. So that was our idea that we sent to you a few months ago.
Okay, great. All right, so that's fine, and you know, I'm sure there's going to be some sort of budget of cost for this type of thing. So if there's some estimate amount, that would be helpful, just so that I can have some idea. So, but it's for 20 students. And then, the last set of things are there other things that the students can see or do while they're there for 1 week? I think most of the time should be that they will be working with people, you know, getting information about the projects that they're working on with local people, and maybe doing some sort of market study type thing. But it might be possible to schedule 1 or 2 visits to a cultural site or I don't know if a company or a social event or something like that, just so that they can have some other experience while they're there in Brazil. I don't want to overload you because I know that there's been a lot of requested of you for some of the other things. So I would just like to minimize, you know, the impact as far as this is concerned, only just in terms of what are possibilities for these 20 people while they're there.
For the Empower trip, which is being organized with Larry and Lauren, we made a sort of a list, and this list can grow when we can choose some of those places that we suggested for that trip to take your students in March. So I think that wouldn't be very difficult to arrange that. I'm investigating even at this point, some more places, which I haven't even told Larry about yet, but I should get a return from some friends of mine. So there are lots of possibilities we can do. Cultural events, depends what they call culture, right? If they want to go and see a samba school, I guess they're not in the right place. But maybe in March, it's carnival time. It's around carnival.
Just after.
Just after, so...
Ashes period.
You should come before and visit carnival, I don't know. So there's some ideas for you.
Okay, great. Well, thank you very much. So I will make some arrangements to travel to visit you guys between the 15th and 19th of December, and maybe we can work out some more of these things while I'm there. But I really appreciate it. I know that we're asking a lot of you, and
so
I really appreciate your time.
So should I reserve a place for you in the fun camp during that period?
If it's possible, sure.
Or will you give me still the correct dates? I think it would be better for me to wait for the exact dates when you are arriving and leaving.
I have those. I can email them to you. But okay. I arrive on the 15th in nighttime. I arrive in Sao Paulo at 10 o'clock p.m. And then I depart at 11:30 p.m. on the 19th.
Okay. All right. I'll see what I can do.
Okay. I appreciate that. Okay.
Sorry, Matt. Is this dates already definite, defined? Are you going to?
I'm sorry, ask that one more time?
Because are you aware you are going to arrive here on a Friday night and leave on a Tuesday? Just after that.
Yeah, I know. Those are the only times that I could get flights there.
Okay.
That,
So you only
I
be
tried
here
to.
practically for the 18th and 19th.
To talk with students and faculty, yeah.
Okay.
I'll show you around, don't worry. Doris is available.
I'm sorry about that. I tried to get earlier flight dates, and literally everything is booked up. I literally couldn't get to Sao Paulo without paying $8,000 a ticket to get there.
No, it's okay for us. I was just wondering if the time would be enough. But if you know that, so it's okay.
That's just sort of how the time has worked out and the flight schedules and so on. In fact, this afternoon I have to get all the visa paperwork in so that I get my visa in time. So, you know, all of this is just very tightly coupled. So, but anyhow, thank you.
Okay.
All right.
Okay. So, have you thought of anything else that I have not thought about?
I think, Doris, one of the things that might be helpful is if there is somebody at the university who deals with setting up conferences or making arrangements so that Matt could work directly with them and get you. I know I don't like to be in the arrangement business, and I want to get you out of the arrangement business. So if there is an office that he can work with and he'll get the buses that he needs through them, that would be fine. If not, we have another possible contact that we've used and we'll go that way. So what I want to do is have somebody other than faculty that make arrangements for visits and housing and things.
Well,
unless you want to be a hotel operator.
Well, how much kickback do I get? Now, let me see here. That this is a bit of a problem. The university has an office for international relations, but as far as I know, they don't do this kind of stuff. But I can investigate if they have some sort of support system there that we can fall back on. I would have.
If not, we're going to also try this other person who set up our +3 trip to Brazil, and he's in Sao Paulo, but he has a contact with a bus company and some other things, and also some company contacts. So I think Matt could probably work through there, and it probably makes sense for Matt to call him and meet with him while he's down there.
Okay.
Maybe on Sunday.
Okay.
On Saturday, no? You're coming on Saturday early morning, isn't that it?
Friday night.
No, I arrive.
He arrives Friday night.
Okay. All right. So if you're going to see this person on Saturday, maybe you should stay one day in a hotel in São Paulo.
Yeah.
Okay.
I think that's a good idea, and then maybe he could be with you on Sunday. If you can, he can come up to Campinas on Sunday.
All right. Sounds like a good idea. Now I would
You can also do scouting from here.
I would investigate if we have some sort of a support system here. We usually do it ourselves in the faculty, but it's a lot of.
Well,
I agree with you. It's a lot of work. Okay.
Okay. So
what else?
Gina Kowaltowski asked me to ask some questions about the GAP conference that's coming up.
Okay.
She couldn't be here. Her son, she needed to pick up her son because he was sick at school. So what Gina requested was she would like to know the lists of names of people who are coming for the GAP conference and know who's coming for the workshop and who's coming for the workshop and conference.
I think what we'll do is send you a form, and then you can fill it out, and it'll be the people that are coming, what they're coming for, and the dates
Right.
that they're coming, and that way we can get the airline tickets and we can get the hotel rooms. So what we'll do is email you a spreadsheet,
All right.
and then you can fill it out and send it back to us.
Okay.
Okay. So that's all that Gina asked for, and those are all the questions that I have. So thank you very much.
One of the things I thought about is, for the architect course, with this interactive software, if you want us to make the contact with Carnegie Mellon, that remember, Doris, you met with Indira in Rio,
Yeah.
and I'm certainly willing to go to Indira and say, we're doing this with you, and would there be interest in their School of Architecture and also getting involved. So if you want me to follow up on that contact, if you think it'll be helpful for you, I'm delighted to do that.
Okay, well, I believe that the software story is about building construction information systems. It's not purely architecture. It's with engineering
Well, we could also-
designers combined. Okay?
We could also talk to our construction management folks and see if they would be interested.
Regina will answer you this.
Yeah, I'll leave that up to you. If you'd like us to try to do some things on our end that might help you, just let me know.
Yeah, the contact with the architecture school would be interesting for student exchange, because our students are very interested in something outside. So that might be a very good idea.
Yeah.
Okay.
All right. I certainly think when you come up in April, we should make sure we set up meetings with them.
All right.
Robert Reese
Yeah.
is connected.
I know.
All right.
As you know.
What else? What's next?
All right. All right. Well, let me introduce you to Mary. I don't know if you met Mary yet, but Mary is working with Lauren on the Empower program, and she will probably be coming to Brazil with Lauren or without Lauren sometime in January to start to talk more about details.
It'll likely now probably be late January or early February. We still haven't heard from CLAS.
Oh, okay.
Okay.
So
Probably better in early February, because January in Brazil is a rather dead month. It's the vacation month.
sounds right.
Late February is Carnival.
And Carnival is late. The 18th
Well, that's
of
what I'm
February.
coming.
No, I understand. But then you should stay in Rio. Get yourself a seat there.
Yeah.
Or a costume and participate. That's even better.
Just don't go to Salvador. I've seen Carnival in Salvador. You don't.
That's wild.
That's mildly putting it.
Okay, what else?
Um,
You're the Mary that I've been seeing messages from.
Right.
Probably, yes.
All right, yes. Pleased to meet you.
Nice to meet you finally. I've heard lots of good things.
Oh boy, oh boy.
Good things.
All right, and then I also wanted to introduce Kim Needy. I don't know if you met Kim, but Kim had asked you about doing a lecture, and you sent a wonderful lecture. So I wanted, I went through your slides. I thought it was fabulous, even without the description. But I wanted Kim to talk to you and see what could be worked out.
Right. Hello, Doris.
Hello, nice to meet you.
Nice to meet you too. And sorry I've missed you. On the trip to Brazil, I had a broken foot and couldn't travel. And then I was on vacation. Actually, I was in Turkey when you were here in Pittsburgh in July. So the class is today at 4 o'clock, our time, local. And so given that we had this presentation set up at this time, I didn't know if it was possible, if you wanted to go through part of the presentation, we could audio tape it.
Yeah,
Or
I think that would be best, because this room, I don't think we can keep it open until that time, which would be 3 hours later. So we can tape it, and then you can replay it.
Yeah, that would work out fine. So
But
that's why
the only
I
problem
brought
would
the
be,
audio tape.
okay, the only problem would be that students won't be able to ask questions, which is fine with me.
Or I can try to answer them and just make up answers.
We don't have the DVDs off of this.
No, I talked to Jim. I'll tell you about that later. Yeah. So I mean, that was kind of the other thing. And on one other note, a PhD student of mine, FICRED, has been corresponding with you, and I believe Amelia Ruschel is a faculty member that you had mentioned that's doing some work in the sustainable water issues related to Campinas. And he sent another note out today, because we would very, very much like to collaborate with her on this research.
You mean Emilia? Emilia.
Yes.
Emilia, yeah, she's at the moment flying somewhere between Rio and Salvador, so she couldn't be here. Okay?
Okay, but yes, we would very much like to work with her on this work. You had identified her as kind of the proper person to connect with us. So we, if you could just, kind of make those introductions for us, and then we will work directly with her, because we feel like there will be some mutually beneficial collaborative research that we can work on.
What was the name of your student?
It's Fikret Turan. His name is F as in Frank, I-K-R-E-T, and his last name is Turan, T-U-R-A-N.
I think it's Polish.
Sounds Turkish.
It's Turkish. Correct.
I do it. Okay. I will tell her when she comes back. Okay?
Thank you.
Yes. What else? That's it?
That's it. If from my perspective, if we want to kind of go through some of the slides.
Yeah, well, if Doris has time to do the lecture and you record it, because we have the slides.
Yeah, we have the slides. Maybe, I don't know if we have time, or if you have time, I should say, to go through. There's, I think, 86 slides.
Yeah, I'm very prolific.
Yeah, my rule of thumb is roughly 1 slide per minute, roughly. So, I mean, I don't know that we have that time, but what we could do is we could go over the slides with the students. I mean, if there was any introductory remarks or summary kind of remarks that you would want to make regarding the presentation, the background on it, or, some of the key takeaway points that it would be important for the students to learn about, we can record, 15 minutes of you talking or whatever.
Okay.
What do you think would What do you think would work out? We do have all the slides and we do have them loaded up, but...
Yeah, well, I mean, slides without somebody explaining what it's all about, sometimes it's kind of...
It's not going to work.
It's not going to work, or it could be rather boring, or it could be enigmatic, sort of, don't know what it's all about. So, I don't know what you think is best. Should I go through them with you?
If you can go through them, if you have the time to go through them,
okay.
that would be the best. Because I agree with you that you can't do the slides without the discussion, without the talk with it. So if you have the time,
I do. I'm all yours. I'm all yours.
All right, then why don't you go through it, and Kim's going to record it, and then we'll play it back tonight. We'll see how it works.
Okay, I would like to just ask, the students are mainly engineering students, are all engineering students or not? Or do they have different backgrounds?
These are all PhD level students, and they're all in engineering. The students in the class are from industrial engineering, chemical engineering, mechanical engineering, and civil engineering.
Okay.
So those 4 areas are represented.
And they are, for the most part, the students that will be coming to Brazil next year.
Okay. All right.
And they are going to be they are learning Portuguese. Some of them are learning Portuguese.
And so we have a 90-minute tape. I have another 60-minute backup tape. But if you want to talk,
I talk fast.
Okay.
Okay. So
We're going to start to record then.
all right. Let's do it then. Okay.
Yeah, I think we're okay.
We have to do something here too? We are recording on this side too, so if all goes wrong, we have two tapes.
Okay.
All right. So this is a talk about bioclimatic architecture. And of course, for you students who are mainly engineers, maybe some of this stuff is a bit boring because it's not your background, it's architecture. But maybe it's just because of that, it's more interesting. So I'm an architect and I work here at the University of Campinas at the Department of Architecture and Construction. And we are also very concerned about the future of our planet and how we architects and engineers have something to do about getting our environment better and feeling better in it as well. Is that okay so far?
It's excellent.
Okay. So if we go to the definition of what bioclimatic architecture is, we will notice that it is mainly referred to as the vernacular. Vernacular architecture is very often connected to bioclimatic architecture because some people historically have built structures which have been reasonably comfortable for their climates, like the famous igloo or the Bedouin tents or the streets of Siena and things of this kind. So bioclimatic architecture is mainly about building structures and spaces which take into account climate and the environmental conditions to help us feel better in terms of thermal comfort. It's not about all types of comfort, which is acoustics and lighting and functional. It is mainly about thermal comfort. So here we have a few examples from the vernacular, but it is also connected to sustainability. And if we read all this stuff here about passive and slow global architecture, about sustainable architecture, we will notice that we are all concerned about, on the one hand, comfort, on the other hand, climate, and on the other hand, using less energy to feel comfortable and using less water as well to feel comfortable. So there's this connection then between bioclimatic architecture and sustainability, which I think is very important to remember during this whole presentation. Another thing is, which I just thought of this morning, you have a very important professor at the University of Pittsburgh who is Phil Hearn. I don't know if you know him. He's in the architectural history department. And he
That's correct.
Yes, he wrote a very nice book called The Ideas That Shaped Buildings. Well, I'm sort of stimulating him to maybe write with us together, and you too, a book which would be called The Ideas That Should Shape Buildings if they are to be sustainable. So there's another connection we can make in the future with the University of Pittsburgh.
I know Phil quite well. And in fact, we actually set up a joint program between architectural studies and civil engineering a number of years ago. So if I can, Phil retired this past year, so I'm sure he's got a lot of free time to work with.
Okay. Anyway, I'm not going to read all these definitions for you because they're on the slides. But as you can see, bioclimatic architecture has to do with all of these types of architectures. and has to do with the concept of green buildings. And there are some definitions which you can find on the internet, what green buildings are. And green buildings are much more connected to sustainability than necessarily only to bioclimatic architecture. So it's a new term, and some people mix up these definitions, and it's not very clear where one ends and where the other one begins. In terms of sustainability, of course, we already have some very interesting rating systems, some in the US, some in Canada, and some in Australia. And Vanessa is our sustainability lady who is working on developing a rating system for Brazil, which should be interesting to see what comes out of it. Now, some green designers to watch. I've just put a few names down here, and I didn't forget Robert Rees, who is your architect, who I'm sure is really working hard and developing some new ideas on how to make bioclimatic architecture in the Pittsburgh region. This is a picture of William McDonough. He's probably the most famous of designers recently, a green designer, and he also has a new book out which is called From Cradle to Cradle, which he wrote with a chemical engineer together. It's a very interesting book that I recommend. Now, when we look at the classics in bioclimatic architecture, we will see that architecture, together with knowledge of biology and climate and applying technology, will give us good bioclimatic architecture. That's the idea of the whole thing. Now, where do we start? Well, the first thing is, of course, you have to know your climate. And you're probably in almost winter there, and we are here in this lower bottom slide. We are with lots of rains, very hot, and storms. So we are on opposite ends of the climate, scale, let's say. So that you have to know about dry bulb temperature, wet bulb temperature, wind velocity, relative humidity, the annual distribution of all this, and whether there are distinct seasons which you can take advantage of. In some cultures, people used to build houses, specific houses or specific buildings for winter or for summer, and then they would move. So that would be really good bioclimatic architecture. You have to have one house for winter and one house for summer. Of course, nowadays this is not done anymore, but this used to be part of the vernacular, which I think might be interesting to know. So learning from the vernacular is because from long-term experience, lots of cultures have known how to perfect their housing needs. So we have the igloo, we have the houses in Thailand, and we have the stone houses in the mountains and so on. And unfortunately, contemporary architecture has had some pretty bad periods where we built these sort of glass boxes and absolutely ignored climate. And bioclimatic architecture is questioning this and is trying to solve these problems and do better design principles and proposals, so we don't have to pump cooled air into them for people to feel adequate. So, but we can learn a lot from the vernacular. The vernacular, most of it is based on high thermal mass. They use a lot of solar radiation to heat in winter. They protect against wind, or they capture wind. So some of these issues here are, of course, important, and we can learn from them. Now, there is, however, when you read a lot of books on bioclimatic architecture, there's some romanticizing of this kind of architecture. And I would say be careful, because not everything that's vernacular is all that comfortable. And if you look at this little slide of Yemen, you will probably say, well, where's my beautiful view? Where's my natural light? So there's something missing here. So we have to analyze these things more carefully and not just adopt them blindly. When green buildings and sustainability came into the design profession, probably one of the first buildings that was mentioned in the literature is the Commerzbank by Norman Foster in Frankfurt. And it had some very interesting, or has some very interesting features, especially new form of building to capture the wind, new materials applied, and new practices, the way people use the building as well. So this building has been studied quite a bit. And one interesting thing is that you should connect with technical analysis also whether people are more happier, are more satisfied, and are more productive. I would think that rating systems should include these kind of indicators. The second part we should investigate after climate is, of course, thermal comfort, and that has to do with our human body. So when we talk about discomfort, we know that we get very sleepy, or we have heartbeat alterations, we sweat more, we don't produce very much if, for instance, the temperatures are very high. If they're very cold, we start to shiver, and we also don't, we can even die from cold, of course, no? So discomfort and health have to do with thermal comfort. The discomfort elements, of course, hot and cold temperatures, too much or too little ventilation, too much humidity, and radiation coming from hot surfaces or from the sun directly. And of course, sometimes we wear just the wrong clothes. We wear a suit when it's 40 degrees outside or something like this, which is of course not a good idea either. Bioclimatic architecture has been discussed for at least the last 50 years. There have been some very good books out, and one of the main representative or experts on this is Baruch Givoni, who used to be from the University of Los Angeles, I believe, and he's also retired now, but he wrote several books which are a great source of information which you could check up on. Now, when we talk about design, we talk about design methods, and bioclimatic design should have certain procedures. So what should we do? We should carefully do site analysis. So we should go there, see, smell, feel, listen, touch, and ask questions about where we're going to build. And not only once, but at different times of the day, at different times of the week and year, because things might change, especially noise and smell might change a lot. So this will affect our design directions, procedures. The careful site analysis further has to go into the topography, whether there are existing buildings around, whether these are barriers to wind, whether there are urban restrictions we have to obey. And then we do this analysis of these interferences, because they might affect our, especially ventilation and shadow or solar radiation problems around the region. After that, we should do an analysis of what's going to happen in the spaces we're going to design. Who is going to be in there? What are the users? What are they going to wear? What kind of groups are going to form? When are they going to do certain activities? And where are they going to do these? So all these details we have to then put together, and usually we call this kind of document that we discuss these issues in, we call it the architectural program. Then we discuss outside activities, where we're going to have pedestrians walking, where we have car movement, parking happens where, should there be shading for this, should there be wind barriers, should there be vegetation so we can sit in the shade and read a book, and things of this kind. And then we get to start designing, and the first thing usually a designer does, he sort of looks at the program and he sort of has an idea of how big this kind of a project is going to be, and then he starts thinking about the form of the building. And in the book by Ken Yang, we have some very interesting discussions of form an appropriate form for different climates. So we have these 4 different shapes here, which he then explains for each climate, an appropriate shape is better. So the last one down at the bottom is the tropical kind of shape, which is a long, thin kind of a building, which you would orient north-south and have the short sides east and west, so you have less accumulation of heat in the morning and in the afternoon. And then you start putting this volume on your site. And there you again have to be very careful with orientation, with the sun shining into your windows or heating up the longer or shorter walls. And this, of course, has to do with where people are going to do things and where you're going to make openings. On the outside, we will have to discuss microclimate. And microclimate has to do with vegetation, shade, and winds. And this top picture is from the what's it called? Do you remember? In Los Angeles, the Getty Center. It's from the Getty Center, and I like this picture because in the local climate of Los Angeles in spring and autumn, you might have people who like to sit in shade, and you might have people who actually like to sit in sun, because the climate is just on the edge of being comfortable in both microclimates. So the designer has to be aware of that and give these kind of spaces to people to choose from. Then we start doing analysis. We should do some shadow pattern analysis over time, so we can see during the whole year where we always have shade and where we always have sun, which might be interesting to know, where we could put a playground or we put a veranda or things of this kind. Then we start refining our design, and the main thing we then get into is the glazing, because we know that glass is the material used in hot houses, so we should be very careful with it in hot climates. In cold climates, of course, we could capture heat through glass, but in hot climates we should avoid them, especially on the facades which are exposed to sun. Now, but then of course you shouldn't do too little glass either, because people want to have a view, people want to be able to open the windows for ventilation. So we have 2 examples here that are both bad. Then we think about solar protection. I'm talking mainly about hot climates today. I'm not discussing so much your Pittsburgh climate because I'm not that familiar with it, so maybe you should have another class in bioclimatic architecture from Robert Rees, who can then tell you what to do over there. But in our climate, we should protect most of our buildings from sun exposure, and this is called the brise soleil, which you should design according to sun charts. So here are just a few examples of what architects do with sun shading. Usually they are used also as decorative elements, and even the shadow patterns can be aesthetic elements in a design. And architects like aesthetics, so this is something we should take note of. Technology has come into this, and this is an example by Jean Nouvel in France, in his institute, which is already some 15 years old at least, no? Yeah, I think so. It's a whole glass facade which has a mechanism which can close and open according to the solar radiation incidence. In some cases, I believe it doesn't work anymore because the technology broke down. But we should be aware that we can design things like this. This might be one of the products, for instance, that your students could design it better or more robust so it doesn't break down. Sun studies are pure geometry, and we have a lot of help there. For instance, for every latitude, there are sun charts we can use. This is in Portuguese, but you can find all this kind of work, of course, also in English. So for solar protection, you need to know the height of the sun and the orientation of the sun, the position of the sun, so that you can design your protection specifically for a certain period or for a certain time or even for a certain half an hour if you want to. Just to go back, some architects in history were very aware of all these problems. Here we have examples of drawings by Le Corbusier, who did sun analysis on his buildings. Some of these things worked and some of them didn't work all that much, but they were certainly aware of this. As I said, in vernacular architecture, we have a lot of very good examples where this was taken into account. Here are some sun charts from our region around Campinas. Okay, we are around the 23rd latitude, not the 24th, which I showed you here, and south, of course, which means that our buildings are turned north and not south when they get sun. So be careful with analyzing buildings from different parts of the world. How do you read these things? I don't know if I should go into this, but the sun angle you read around the circle, and the solar height you read in these concentric circles on the right of this example here. And how do you read the years? They're on these lines, and the hours are the blue lines on the right. And you have to do some geometric transformation of the angles, because you want to exactly know the sun patch on a specific plane. So then you have to do some geometry here, which I'm sure you're very good at. We can use some auxiliary charts which help us simplifying the design of sun protection. I won't go into all of this because it's all in Portuguese, but we teach this to our students, to our architecture students. Our engineering students, sometimes we have some special classes for them, the ones that are interested. So then, how do you do the protection? The protection on windows especially can be of all sorts of shapes, as I've already shown. And the angles you get from these sun charts that I just showed you. Now, Mother Nature is very nice to us and helps us. So in summer, the sun is higher, and in winter, the sun is lower. So we can use the winter's sun to heat, and we can just protect ourselves easily by extending our roofs on the north facade here and the south facade over there where you are. Here's just some more studies we can do. Here's some other studies, and sun angles, summer, winter, spring, and autumn. And then we get to the roof. Well, the roof is very often called the fifth facade in buildings because it is exposed to the sun, and it actually is the facade that's most exposed to the sun. So we have to really take care. And the main thing in bioclimatic architecture is to try and reduce the area of the roof and to protect the walls through the roof by doing long overhangs. And the third part is to try and make roofs in such a way that the hot air which accumulates inside the building can escape from the top of the roof. So you should put some openings there. You should also put an air cushion between the last floor and the roof. You should put an air cushion, which is a good insulation material, and it's cheap. You don't pay for air. Now, in our climate, there's another roof feature which you should introduce, is the veranda, which protects the walls from rain. And when it rains, it usually cools down here, so you should keep your windows open. So a veranda helps you to do that, because then you can protect yourself from the rain. Roof openings on top are very good to scoop wind and to let hot air escape. So the shape of the roof is a very important feature in bioclimatic architecture. Here we have an example of a design by James Wines, where he used undulating strips of roof, and the curves that don't meet, so you have openings which introduce light, and you can make the air escape and do openings in this. This project was never built, but it's a very interesting kind of feature that you could use as a design feature. This is a design by Ken Yang, who is a famous architect from Kuala Lumpur, from Malaysia. And this is probably one of his first designs, where he sort of put a gazebo over his house, sort of a second roof to protect the house against sun radiation. According to this picture on the side, the photograph, I am not sure that it works for all seasons, but the idea is interesting. Here we have a design by Glenn Murcott in Australia, where he uses the double skin method for the roof. So he has an air cushion between the ceiling and the roof cover, so that he has a better insulation against radiation on the heads of people. When we build with slabs, we have to be very careful, and we have to introduce an insulation layer. And of course, there are all sorts of other things we have to take into account, like rain problems and people walking on top. In general, in tropical climates, insulated slabs are a problem because of the temperature gradient you can get on the top surface and on the bottom surface of the slab. Sometimes these temperatures can vary up to 40 degrees, and then you of course have movement inside your materials, and then you have cracks, and then the cracks get worse, and then you of course have rain problems. Glazed roofs in hot climates are a real problem. People love them because they're beautiful, but of course they become hothouses. So we have to be very careful where we use them and how much we use them and how we protect them. I always recommend in our climate to use glass roofs only in areas where we spend a short time, where we just walk through and where we don't stay. So, for instance, in corridors and stairways and things of this kind. And then we can even introduce a sundial, which would make it more interesting, and use the sun to tell us what the time is. Glazed roofs can be used, but we have to be clever with them and introduce shading possibilities and take hot air out. Here's a design by Norman Foster of the German Bundestag in Berlin, where he actually uses this glass dome more as a memory feature. It's more of an aesthetic element, because the building before the Second World War used to have a dome, and this dome was destroyed in the war, and so he reused it, but he's not using it the way it used to be used. But he introduces light into the main room of the parliament, which is down below, and it's for tourists to walk around, right? So it's a very interesting construction, but it's not a place where people would be staying and working in. Other roof technologies, we have Calatrava, who designed and built this museum in Milwaukee. I have not seen this building, but supposedly the roof has these wings, and they close according to the necessity of too much or too little sun. You can also
We just dropped out.
have a problem here.
Yeah, I have to, I don't know if it timed out, or, let me try.
Am I talking too much?
No, you're fine. No, we can hear you just fine.
You know what, as long as you have the audio, it should be okay.
With the audio, yeah.
Okay.
Just keep talking, and we'll try to bring you back up.
Do I go on? Okay.
Yeah.
Yes.
Okay. So, bioclimatic architecture, as I said, does not have to look like vernacular architecture. It can be high-tech. For instance, we can use photovoltaic panels, take advantage of certain conditions, and heat and cool our buildings and run our machines through electricity brought in by the sun. Special attention and detailing in roofs I've already mentioned. Here we have an example where you can open the roof and take advantage of letting hot air out, or bring in cool air, or bring in light. The next feature for roofs is green roofs. This is it's not even a recent invention. There have been green roofs in the vernacular. And green roofs are good because, first of all, you have thick construction, so you have really a thick layer of insulation. So the heat gain is not as fast, and you have a much higher thermal resistance. Of course, that you have some disadvantages because green roofs are much heavier, so your structure will probably have to be much more robust. And also, you have to maintain these green roofs. And in our climate, for instance, everything grows very fast, so you might have to put some sheep or goats on top of your roof to keep the grass short. And be careful that birds don't drop seeds, which then grow into huge trees. So green roofs are interesting, but we have to look into the detailing of how we maintain that. Then further, after roof construction, we should think about ventilation. And ventilation in tropical climates is probably one of the main and most important features to make us feel comfortable. So Ken Yang, who works in a tropical climate in Malaysia, has designed skyscrapers without air conditioning. And he designs here the shape of buildings so that you would catch winds. And how do you catch winds? By making them rough surfaces so that the wind gets caught up into these little details and goes through the building. Here we have one of the designs of his, where he applied these principles of his. In Brazil, we have an architect called João Filgueiras Lima, who is very clever also with his ideas about bioclimatic architecture. And he uses a lot of ventilation ducts under the buildings, where he would capture breezes coming from the sea and increasing their speed by introducing a very slow fan coil, and then introducing still some water spray to cool down the air, and then he would introduce this conditioned air into the building. So it's a very simple way of cooling, and you don't have to have air conditioning. Just one fan and a bit of, it's sort of like evaporative cooling. And here we have these ducts showing on the right, on the left, and on the right we're seeing the hospital where it's the way it's designed. So the air comes in at the bottom and leaves at the top on these wavy ceiling slabs. So this is the whole idea, that you should have openings at the bottom and openings at the top, so exit and entrance of air coming through the building. And when we enclose buildings, we should always be very careful to leave small gaps so that the hot air could escape. Or you could see this in this drawing on the right, which is just a little detail, but it makes a big difference in terms of the air which would go into the window, which would be open in this case. Next, in terms of ventilation, the importance of cross ventilation. So you should have openings on two sides. In school buildings, there is a rule in Brazil that all school classrooms have to have openings on both sides. In school buildings, it's a problem because of noise in corridors. So here are some examples of how you might solve this problem, so that you put the opening above the roof of the corridor. In antiquity, we already had people thinking about ventilation. So we have the Pantheon in Rome, which had the openings at the top, and you can actually visit this building nowadays, and when you stand in the middle, you can feel the ventilation on your body. It's actually really great noticing the sensation when you go into it. However, I want to make note of care here, that architects use design in drawings. We use drawings. And on drawings, we put these lovely arrows, which tell us that there will be ventilation. But if we don't test this properly, we are not sure that this is going to happen. So let's be careful with our imaginary arrows on drawings. In Brazil, we've had some vernacular architecture which took advantage of sea breezes, and people built these sort of towers where they would sleep at night and capture the sea breeze. Unfortunately, this is almost not in fashion anymore because air conditioning has come in, as in most countries. But it was a very clever way of being able to sleep in a very hot and humid climate in the northeast of Brazil, where you always have a sea breeze. But the sea breeze only happens above the main urban tissue of all the buildings. In the United States, in the southern part of the United States, you used to take advantage of night ventilation. And there are houses in the southern part of the United States which had huge fans installed in the main hallway, which then would be turned on when when night came in and the air outside was cool. You would open up windows at the bottom of your house, turn the fan on, and take out all the hot air from the house, and then you would be able to sleep perfectly okay without air conditioning because you exchanged the air. So this is called night ventilation or night cooling, and it can still be used. However, with air conditioning, most of these buildings nowadays don't use these very interesting fans anymore. The chimney effect, I should go back here. The chimney effect can also be used, but the chimney effect has to be very carefully calculated because it doesn't happen if you just open a window at the bottom of your room and at the top of your room. You have to have quite a high height difference and a temperature difference. So there have to be very specific conditions where you can take advantage of the chimney effect in bioclimatic architecture. Then we come to construction detailing, and there we have to choose carefully all the types of materials and the layers and the thickness of the materials that we will put, so we don't gain heat or lose heat. And we have to shape our building again to protect it from sun and to catch wind. Color and material also have something to do. Color, for instance, white reflects heat, so we don't gain heat when we whitewash our buildings. Therefore, in Greece, in summer, all the buildings are whitewashed once a year, so they don't collect heat in summer. Black, of course, would be good in very cold climates, so you would actually accumulate heat from the sun. And then lastly, we go out after we've designed our building, detailed it, thought about all those things that I've talked about. So around the building, we should think about putting vegetation, because vegetation, due to evaporative mechanisms, cools the air, therefore creates a microclimate. We get shade from trees, and we absorb heat on grass and leaves of trees and things of this kind. So vegetation helps us a lot around our buildings. And vegetation can also be used on the building as a second skin. For instance, ivy grown on a building can be an insulating material. Here we have some examples how architects have introduced vegetation into their buildings and worked actually the design with vegetation. And here we have older examples of the second skin through ivy. When we use vegetation, we have to be careful of thinking about the seasons and of thinking about growth, because things change over time. On the left side, we have two suburbs, 20 years apart. So we have one with trees already nicely grown and one still getting a lot of solar radiation because trees haven't grown yet. So the comfort conditions in these both suburbs are probably quite different. Again, Mother Nature helps us. In winter, trees lose their leaves. Not all of them, of course, but deciduous trees do. So the sun can heat us up, even if we have planting around our buildings. We can put vegetation inside buildings, which doesn't really work as well as on the outside, but it gives the psychological effect that we are comfortable. Another factor is water. Water can provide evaporative cooling and a sensation of freshness, of coolness. So we should use it on the outside around our buildings. We should also pass our ventilation across water, because then the temperature will drop when it goes into the building. Again, I'm always talking about hot climates here. When we're talking about cold climates, we have to be careful about these kind of phenomenon and maybe avoid this kind of air movement coming into our buildings. Water is, of course, also aesthetically used, and also because people are attracted to clean water. So architects love putting water fountains around and water mirrors around their buildings so that they have them twice in the magazines. Now, in water pools, we have to be careful with children because of drowning, and of course also with insects, with dengue. Dengue is caused by insects who breed, by mosquitoes who breed in standing water. So in our climate, we have to be careful with water pools. Okay, so then we come to the end, and design is not just drawing and making pretty pictures, but design is testing, calculating, simulating, and analyzing. And here I've put 10 steps to bioclimatic success together for you. I'm not going to go over them because I went already in my lecture over that, but just for you to check, maybe when you're doing a design, you might use this as a checklist. And my final considerations are then that after we design and detail and test our building, we build it, and we should go back to it. I always say that architects and engineers should go back to the crime scene and assess whether the building actually is bioclimatic and is comfortable and is successful and people are happy in it. And then we should maintain these buildings and, if necessary, renovate them or remodel them. I've already mentioned that comfort is not only thermal comfort, but there is acoustics, there's lighting, and there's function, which all play a role in comfort, and they all are related to thermal comfort. Just one example, for instance, we, in our climate, always recommend open windows, but if you are on a noisy street, you might not be able to do this. So how does bioclimatic architecture work when you have acoustic problems? So there are some things which we designers really haven't gotten answers for yet. We have to still do a lot of studying on some of these problems that I've put up here for you guys. Again, bioclimatic architecture is not able to be done everywhere. If you have very low temperatures or very high temperatures, just the building will not really be ever comfortable. So we might have to think of some mechanical ways of heating or cooling in these kind of climates. And lastly, the users should be involved. It's not just the building that can do it by itself. For instance, you have a building where you can open windows, but nobody does it. So what are the windows for? So we should somehow also get our users involved in thinking about their comfort levels and how they would participate in making a building comfortable. They can, for instance, wear better clothing, they can move out of the sun or out of the wind, they can maintain the windows clean, or the roof, or the walls which are white, or paint them, and things of this kind. And here I put a few challenges for the students to maybe think of some creative new ideas which could be introduced into bioclimatic design. Then I've thought that maybe we should discuss some economic issues and the building industry. Because if we think about sustainability, it means to reduce economic activities on the one hand, but on the other hand, economic activities thrive on increased necessities and new necessities. So there's a paradox here that we may have to discuss. There are a lot of social issues involved. For instance, the spending power of people. What kind of buildings can we propose for poorer populations? Also cultural issues. What kind of habits do people have? What do they like? What do they dislike? These all influence whether a building is a success or not. Then there are some other issues on how can we as a designer, as an engineer, as a user and a citizen do to really promote bioclimatic architecture. And then to maybe get some ideas, we should look back at history, because in history we've had some crises. We've had energy crisis, we've had shortage of water and other shortages, and people somehow managed. So what were the clever ideas that we had in history that we forgot about and that we maybe reintroduce into our building industry? In relation to this is historical inventions in the vernacular. We should maybe start making a list of some really clever ideas which were lost in time. And then there are other challenges, and how do we become creative? Creativity in design is, of course, always seen as something very important. So here's a stimulus for you guys to maybe think of something new, some new materials, new products, new places to live or build, new shapes to invent. And some of the ideas might come from brainstorming, from analogy, from biomimicry, for instance, is being explored a lot nowadays in bioclimatic architecture. Maybe we should need new clothing or walk around naked again, who knows? Okay. This is the table that TRIZ is based on. Maybe you should investigate this and find some ideas exploring this table that this person called Altshuler invented as he was sitting in the patent office in the middle of Siberia. Who's not familiar with this, it might be interesting for you to investigate him. Here I put some other ideas on how you get new ideas through combination, through mutation, and through going back to first principles. Engineering students are very good at these kind of things, and architecture students should learn in using these kind of methods. And then more challenges come from the agendas, from the books, from literature. So maybe we should reread some of these agendas and get some new ideas. I still have another question is, with global warming, is all that discomfort we're feeling going to be enough for us to really change our built environment? There's a question for you guys. Maybe it is, maybe it isn't. I think at this point it isn't enough yet. We're not uncomfortable enough to really do something about it. So we need more stimulus. We need to broaden our focus. I've been using some slides here from the presentation we did in the Rio Engineering Education Conference, which was very interesting and where I presented together with Larry. And we should remember that we will have an opportunity to discuss all this in April, and we have lots of people who are supporting us. So this is the end. I hope you enjoyed my little talk.
Doris, this is fantastic. Although I think we had some difficulty with the visual portion of the presentation, we have captured all of your remarks on the audio tape, and tonight during the class, I will play that for them, and I've been taking meticulous notes here to supplement, kind of some of the things that you've said, and hopefully I can page forward appropriately.
Okay.
So I think, yeah, this is just terrific. We really appreciate you taking the time to do this today.
I was a bit worried about level, whether this is the right kind of level, whether this is too general or not technical enough. I just wondered whether we should get some, we should definitely get some different kinds of talks on the same subject, but which would go into some of the areas more deeply, especially for engineering students.
Yes, we've had a variety of different presenters each week, from law, from economics, from different disciplines in engineering, architects, etc. So this is nice. Much of this has not been repeated thus far this semester, so it's going to be really useful. And in particular, I really like the 3 or 4 slides you have at the end on challenges, because this course is really meant to be an introductory course in sustainability, and for most students that we have, it's their first exposure to this. And we're really trying to present it from a broad perspective on the water side and the green construction side, to really start sparking some interesting research questions that they might have. So for example, the industrial engineering students may be most interested in approaching this research area from the engineering economic side, or maybe from the human engineering side and from the productivity side and what the impacts are, etc. And other engineers, the civil engineers, may approach it more from the perspective of actual building design and construction management. And so the questions, the challenges that you raise speak to a couple things. One, they really do show the interdisciplinary nature of this problem, and how people from various different disciplines are going to approach it differently. They're going to be interested in slightly different problems, etc. So I think what I will do tonight, because we have 2.5 hours with the students, is we can kind of go through this presentation, and then I think we'll put the students into some groups and have them maybe start thinking about some of these research challenges to see what kind of ideas that they can come up with, because in the future portion of their studies, they are going to need to really then start focusing on specific research topics with which they'll get started here, and then they'll be coming to UNICAMP to work with you and the faculty there to kind of extend this work.
Okay, so you'll give me you'll give me some return on what the students thought, and maybe some discussion ideas which came up, so we can discuss them further. Okay?
Yes, we can do that. We will have them complete a short survey at the end of the presentations on, we ask them, what did you know about this subject before hearing the lecture? What do you know about this subject afterwards? And, kind of, what did you like about that? So we can definitely share that with you. And then in addition, we can share some of these findings from this little brainstorming session that we'll do afterwards. We'll be happy to share with you.
Okay.
Okay?
Yes. That was very good.
I think that's it. I'm the last one still standing here. So.
Yeah, we're sweating here, and you're probably cold over there. So
it's very cold in Pittsburgh.
Yeah, you tell your students that we're sitting here in an air-conditioned room, but outside it's around 30 degrees centigrade. Now they would have to convert this by dividing it by 5, multiplying it by 9, and adding 32, which I guess is around 90 degrees Fahrenheit, I would say. And relative humidity, relative humidity around 100%, because it's probably raining.
Wow. It's 30 degrees here also, but Fahrenheit.
Yeah, okay. So, Bioclimatic architecture has to be different here and there.
Yes.
Okay. So
Well,
that's,
thank you so much, and I definitely look forward to meeting with you all in April when you're here in Pittsburgh.
all right. Okay.
Thank you.
Next, I'll say goodbye then.
Okay, bye-bye.